Okay, so you looked at arithmetic sequences in series last month, and some of you have already done this section, so you're fine with it right now. Well, what we're going to do is a couple of things I will emphasize and focus on that I want you to do. So, first thing here, we're going to write an equation for this sequence and then find the amount of the 15th term. So in order to do that, well, the type of equation, well, actually, let's start, I'll do this in A, B, and a C. So you need to find the common ratio. You can see on something like this, it's really pretty easy. To get from 4 to 12, and then 12 to 36, and to 108, it's times 3. But sometimes they're not so simple. Sometimes it's like a 2.4 that you multiply every time, and you can't see that in your head so easily. So the technique you want to use to do it is you take the second one and you divide it by the first one and you get a ratio. But then you take the third one and divide it by the second. 36 divided by 12, and that should come to the same exact ratio. And when you do it with the fourth one divided by the one in front of it, it better come to 3 or else there's something wrong. So 108 divided by 36 is indeed 3. So now we see that that's the common ratio. Okay? We need that for the formula because the equation has to be in this format. That's the format you use for a geometric sequence. So what this is saying, the amount at a certain term number, whatever number, 10th, 15th is what we'll figure out in a few moments, is equal to the amount of the first term, which is pretty easy to determine, times the ratio raised to the power of the number of the term minus 1. Now the number of the term we don't know yet. We'll put 15 in there for the second part of the question, but right now it's supposed to be generic so that you can put in any number of terms. These are the two we have to fill in, and we know them. We know the 4 for the first term, and we did this to figure out the ratio. So the amount of the nth term is equal to, oops, I meant to put the number 4, times the ratio raised to the power of n minus 1. Unlike the one that's arithmetic, where you have parentheses and you can multiply it in and you can simplify it, which some people didn't do on the test, so you have to make sure you do that from now on. Always simplify everything. You can't simplify this one. There's a temptation to say, oh, great, 4 times 3 is 12. But, good, some of you know, this is order of operations. You have an exponent. So if you do 4 times 3 to 12, well, you actually learned somewhere about 4th grade not to do that. So this is the time to apply what you learned in 4th and 5th grade. So that is the actual formula. And then the last part of this is for the 15th term, a to the 15th power is equal to 4 times 3 raised to the 14th, because it's n minus 1 if I put 15 in here. Now, I could get this, I'm going to do this in a second, but I could get this by multiplying by 3. So next I'd have 324, and then I'd have 972, and after that my brain can't quite do the multiplying so easily. So you keep multiplying by 3 15 times. Nothing wrong with that. If you do it by calculator, it'll be a little faster because the number that you get is 19,131,876.
Wait, did you just choose 15 like randomly? Or?
Yeah, randomly. I chose it large enough of a number so that you wouldn't be tempted to multiply by 3 and not use the formula. Because if I had said the 7th term, you probably would have thought, I could just multiply 4 more times on here and get to the 7th term. And you could, and you'd be right. But if 15th term, by about the 10th term, you're going to realize that that's a little too much multiplying, and the chance of making a mistake is a little too easy. So using the formula becomes a lot easier. And so sometimes that's why I pick the numbers, just to make it large enough to make you use the formula. So it becomes a pretty big number, 3 to the 14th power, and then multiplying by 4 to it. Okay, now, the second thing that we're going to do in this section is to find the geometric means between two numbers. The mean is just the average. With arithmetic things, you just add up two things and divide by 2, and you get the exact middle. But this is not a straight line kind of thing. This is a curve, you go up faster and faster as you go on. So that means that the numbers in between sort of, it's different. And plus you're looking for 3 of them. So what we have to do is figure out what we're multiplying by. We're not adding on these, we're multiplying. So we have to find a way to do it, and here's the method, one way that you can do this one. Find my notes, make sure we got it. Yep. So if I only knew what number to multiply by, I could use that to get this. And if I knew that, I could multiply to get it, I could multiply again and get that one, I could multiply again, and then I'd multiply again and be certain I was right. Here's how you do it. We're looking for the ratio. This formula, AN equals A1 R N minus 1, well, we don't know the ratio, but we do know the first number, because that one's given. We also have enough information to fill in the amount at n and n if we pick well, because we're given the 5th term. If you think about it, you're not only given the first term, you're also given the amount of the 5th term. So if we say that n is equal to 5, and then the amount at n is equal to 49.22, and I can put a 5 there, I can put this over here, and I put the 5 in there, and put the 3.12, and I can solve for r. There's only one variable left, so I can solve it. So let's do that. For the AN is going to be 49.22. That's the amount of the 5th term, is equal to the amount of the first term times r raised to the power of 5 minus 1. So I just simply used a point. I was basically given a point. This is like when you want to solve for this in the slope-intercept form. You have the slope and you have a point, and you want to find what the y-intercept is. You plug in the x and y, and you can solve for b. That's what we're doing here in just a different way. So now we have to solve for that, and it's a little bit different because of the fact we're going to have an even number here. Let's sort of see what's up. Oh, 3.1, I have to do 49.22 divided by 3.12, r to the 4th power. That comes, if you do that on calculator, you see you get a nice, simple, easy 16. So what we now do, r to the 4th, I like to put it over this way anyway, I am going to do the 4th power of r to the 4th and the 4th power of 16. What number is that? What's the 4th power of 16? 2. Yes, you're half right. What?
Plus and minus 2?
Hmm?
Plus and minus 2?
Plus and minus 2. It's positive and negative 2. If it was an odd number, a negative number would just do itself. Like 3rd power, 8 is negative 2 times negative 2 times negative 2 would give you a negative 8, and there's no other possibility. It's not a positive 2 unless you get a positive 8. So you can actually take like the 3rd root of a negative or the 5th root of a negative. But to get a positive and it's an even index, you actually have a plus or a minus, because negative 2 4 times will give you a positive 16. Yes?
Charlie pointed out something.
It's
Yeah.
not a perfect 16.
This number didn't come to 16? It was supposed to?
It was a 15.7 something.
Oh, I know why. Yes, you are right. And the reason why, let's go back for a moment. When I wrote this out and copied it down, this is supposed to be 49.92. So please change that to a 9, that to a 9, this to a 9, and this to a 9. I have that written just like that on my papers over here, and I just realized I just did a typo, hand typo. So I apologize. Thank you for catching that, because now it will be correct. If you do 49.92 over 3.12, that should come to 16. Okay. That's what I planned at least. So we do get 16 if I could give you the right number. Now that means that this is equal to the plus or the minus of 2. This only happens when you have even indexes. So that's one thing to remember. If this had been a 3rd or a 3rd power or a 5th power or 7th power, no issue. Then it's either plus or it's minus based upon the number. But if it's an even number, then you're going to get plus or minus. What that means now is, let's use positive 2 first, and then we'll use negative 2. We have 2 r's, which means we have 2 sets of answers. This problem is going to give you 2 sets. So you have to watch for it, because some of us teachers are tricky and we'll give you that, or we won't give it to you knowing you'll look for it. You can't be sure which way I'm going to do it on the test, but you have to be ready for it. So 3.12 times 2 will give you 6.24. Times 2 again will give you 12.48. Times 2 again is 24.96, if I have it right. Okay? And then we get the 49.92. So this is one set of answers. If I multiply by negative 2, 3.12, I'm going to get a negative 6.24. And then a negative 2 times that, the negatives will cancel out, so we're back to a 12.48. And then a negative 2 again, now the negative is back in there, so we get a negative 24.96. And then multiplied by a negative again, we get the positive 49.92. So this set of answers works too. Because both of these are positive, you can have a negative because the negative cancels out inside. It's not till the number after 49.92 that the negative comes back in. And because I didn't give it to you, you don't know whether it's negative or positive. If I had given you the next number in line and it was positive, then you would realize that you could only use this set. Because the next number in line after this, I'd have to take this and I'd have to multiply by negative 2, and it would be a negative if the negative 2 is right. Since I don't give you that info, you have to give me two sets of answers. This problem requires two sets of answers, these numbers and these numbers. Okay. So that's the stuff to watch out for here on this. The textbook shows this kind of stuff, but it doesn't emphasize that you could have one or the other and why it disappears, why it's okay to have negatives for some of them. Okay. Any questions about this one? Okay. Let's take a look at the third page that you have on the handout. And when you're doing a sum of these things, now that's also part of the vocabulary of this. Back on the first one, when I started this, geometric sequences and sums. In fact, I wrote series or sequences and series. I crossed out series, realized I put the wrong word, because a sequence is just simply a list. One of them, the next one, with commas. A series is where you have one, you add to it the next one, you add to it the next one, and you get a total. So getting a total is what you get for a series. I don't know why they chose that word for it, but that's the vocabulary, that's the word. You just got to get used to it. Okay. So we can use one of these two formulas. They're very similar, but look at the difference. You would use this one. In order to use this one to get the sum, you have to have the first term. You have to have it in there twice. But you also need to have the r, and you have to have the n, the number of the term that you're looking for. So you have to have those three things. On the other one, you need the first term, and it looks like you do need the r, but the difference is you don't need the number of the term. You need the amount of that term. So you need the amount at that term number. Like when we found the 15th term before, I could have used this to add up to the 15th term. Here I would just put a 15, but here I'd have to put that number, the 19,131,876. Yeah, I don't want to use that large of a number either for it. So using this formula depends whether you know already the number of the term or you know the amount of the term you're trying to get. So let's take a look at this one. And sometimes you might have that stuff or miss one of them, and you might be looking for one of these in order to know the sum. So what we're going to do here is we're given three numbers, given this sequence, and we need to find the sum through the 10th term. It is possible with this to just keep doing, well, let's see, first let's find r. It looks like times 5, it looks like times 5. So I could do times 5 7 more times. I'm going to get a pretty big number, but you know, if you want to sit down and do all that, it's possible. But I'm going to require you to use a formula for it. So let's see what we do. Okay. So right now, we have the first term, a1 is 6, the r is 5, and we want to go through the 10th term so we know the number of the term. That means that this formula is probably the easier one to use because we don't know this one at all. In fact, we couldn't use this one because we're missing two different things. We don't know the sum, and we do not know the amount of the nth term itself, whatever that 10th term is. But knowing this, we can plug those in. So that means we can say the sum at the 10th term is equal to a1 minus a1 again times the ratio 5 raised to the power of 10 over 1 minus the 5. So you can plug in all of those, and after that it becomes a calculator exercise. If you put everything in the right place, use your calculator well, then you can get the answer for it. So this one, I'll sort of work through the steps on it, just as a reminder that first you have to do this. And if you do, you get this number, 6 minus 6, 9, 7, 6, 5, 6, 2, 5. Let's see if I transcribe that correctly. Yep. Over -4. Sometimes you see this formula with the A1, like A1 parentheses, 1 minus the other thing, which is possible. This is easy enough. And then you can multiply the rest of it. You multiply this, you're going to get a negative. The overall total comes to 14,648,436. It's positive because this negative and then this one after you multiply it will be a negative number. The negatives will cancel out. So any questions about using that formula? You really just have to identify with the information given to you if you have enough info to use this one or if you have enough info to use this one. And the difference is the number of the term or the sum. And I think I have a problem, no, one of the ending problems we have, I think we'll do the other way. I think we're finding the first term, or we'll play with it. Okay, let's look at the next page now. This one is using summation notation. And that little symbol is really not, it's imposing to some people, not a big deal. All it really is just directions. It's telling you, find the sum from the first term to the 12th term of this series. Right? So it's just a matter of you just have to write the series out yourself. You can find the first term here by plugging in a number and work with that. In fact, look at the format of this, and if I'm nice to you and I give you this format, then it's easier to use. If I play with it, then it's not so nice. But most of the time it comes in this format. Let me find, remember, I'll write it here, remember that the amount of at a term is equal to the first term times the ratio, and then raised to the power of n minus 1. Look at the format. So that tells you right now what the first term is, and it tells you what the ratio is. So we now know two things. And this is written so that it tells you what term you want to start the adding with, and what term you want to end the adding with. Now, I could have written this as, say, 3 to 12, in which case we would not be using this number. Let's say 4. Say I made it 4, there's too many 3's in there. If I said the fourth term, I wouldn't use 3. 3 is the first term. I'd have to multiply 2 to get 6. That's the second term. Multiply 2 to get 12. That's the third term. And then I multiply 2 to get 24. 24 would become my new first term. And then I would be going from the fourth term to the 12th term, which is a total of 9 terms. So my n would now be 9, not 12. So I'd have to adjust that. So like, here's the series. I only want this part of the series. So I need to throw away the first 3 numbers, and I need to readjust and say I'm going from the first term to the 9th term of a new series, where I'm going from 24 to whatever the 9th term, or the 12th term used to be, is now the 9th. We're going to do this first with the 1 here. Okay? So if n is equal to 1, we're going up to 12, that means my n is 12. The n for this is 12. This n is just telling you starting with the first one. A1 is 3. And R is 2. So I have enough information here to use the sum formula from the last problem. Did I use it? Which page was that? There it is. Okay, so I will use this formula because I have the A, the R, and the N. So I'll say the sum at the 12th term is the third minus the third times the 2 raised to the power of 12. All of that over 1 minus the 2. Okay. Yep, looks like that, right?
Isn't it 12 minus 1? At the top, where it's n minus 1? Is it 12 minus 1?
Oh, the n equals 1, you mean?
No, already there.
Oh, it's n minus 1, you're right. Why did I put it? Oh, okay. This is that formula to help you find each number in turn. So if you put a 1 in here for the first term, 2 to the 0 is 0, so you get a 3. The second term, If you want to know the second term, you put a 2 in for n. 2 minus 1 is 1. 2 to the first power is 2. 2 times 3 is 6. This is used to get you each number, each term that you want. This formula is different. This is the sum formula, and that one has just an n. That's a good thing to mention, though, because you use, sometimes these formulas have an n, sometimes they have an n minus 1. One of your jobs is to distinguish which one is which and when you use them, because it can be very confusing as which is which. So you made me think about it in order to determine it, which is a good thing. So the formula for just getting each term has an n minus 1, but the sum formula has that. The other sum formula doesn't even have an exponent, so it's not a problem, which is why, you know, that's good for other times. So now, if you calculate that, it comes to 12,285. I don't do it step by step usually. I usually do the 2 to the 12th power, I multiply by 3. Actually, sometimes I put it in like that with parentheses, and then divide it by the -1. Okay, but you get this number for the sum of it. Pretty easy to do once you find out the information. Okay? So from this kind of setup, you can just simply figure out that info. Now, this is not one of the things in my notes, but I realize it actually would be good to do. Underneath it, let's call this A, and let's make a B here. I'm going to do the same thing, except I'm going to say n equals 4, like I was explaining it verbally. I think it's going to help to see it visually here. I'm going to use the same 3, 2, n minus 1. Now, I don't have any written directions on this, because this sigma notation, this sigma sign, is itself direction. When you see that, just right by itself without any English words around it, it's telling you, find the sum of the series from the 4th term to the 12th term, where the formula for the series is this, 3 times 2 raised to the power of n minus 1. So I would normally say that the first term is 3. That's great, but it's not going to help me since I need the 4th term. So let's put a 4 in here. Okay? So I'm going to say for n equals 4, I'm going to do 3 times 2, 4 minus 1 is 3. 2 to the 3rd power is 8. So that means it's 24, which I figured that out before. Now we've got it written down that the amount at the 4th term is 24. So what we now know is we know the first term, for us the first term, is going to be 24. And we're going the 4th, the 5th, the 6th, the 7th, the 8th, the 9th, the 10th, the 11th, the 12th. That's 9. 12 minus 4 is 8. Why is it 9 when 12 minus 4 is 8? This is a big, important thing.
Yes.
So you have to add 1 to the...
You have to add 1. This is inclusive, meaning it's including the beginning and the end. So when if you do a simple subtraction, that's not wrong, but you have to put it in your mind that you're going to have to add 1 back in, because you're including that 4 and you're including the 12. Usually, if you add a number like 4 and you start counting, you go 5, 6, 7. You don't include the 4, but you have to here. So you want it in your mind. That's one of those things that people tend to make mistakes on because they just don't think about it. So I would say, make a little star and say 12 minus 4, but plus 1. Something like that to remind yourself that you have to, you can do the simple subtracting. 4 to 12 looks like it's 8, but then remember to add 1 into it. Okay? Otherwise, you end up with the wrong answer. So, okay, so now I know, in order to do this kind of thing, I have lots of information here because I know the n is a total of 9. The amount of the first term that I'm going to use is 24. The ratio is 2. I also know the amount at this term, 24. So I now have 4 pieces of info. These 2 formulas, the available formulas, let's move this up here. The available formulas, this one I need AR and N, and I've got them, A1. This one I need A1, R, and AN. Well, I have AN too. So it doesn't matter, I can use either one. I'm going to be right no matter which one I use. So I just to be different, I'll use the second one this time. The sum at the, okay, we're doing 9. The sum at the 9th term is equal to the A1 is 24 minus A1 times 2. No exponent on this one. In fact, what I should do is put it here. I'm following this formula. 24 minus 24 times 2, and 1 minus the 2. That seems so easy that way. No exponent. It just seems like the numbers are easy, but, and, yep, so I needed the, oh, I see, nope, I don't see what I knew something was off on it. The first term's 24.
Wait, for the S, would you, how come for the first one you put like S12, and then for this one it's S9, like this one?
Yeah, it's the ninth term. Okay, first I'm seeing something else I have to watch out for here, because I don't know, yeah, okay, I'm jumping here. Let's watch out here, because I just realized the mistake I made, and that's I should have used the 9 up here, or the 12 rather. Okay, first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, when it was 1 to 12, we used all of these. When it's 4 to 12, we're using these here. This becomes my new first term. That's the one that's a number 24. What I did here is I shouldn't have this should be the A of the 9th term, which means I need to put the 12 in here to find what my new, because that's originally the 12th one. So let me back up and let me put a 12 in here, okay? So n is 12, it's 3, 2 to the n minus 1, so it's 11. Let's calculate that, because then I can use this formula, because this number is not 24. I'm glad I looked at the formula, because that reminded me I need the first term, but this would mean to be the amount of what used to be the 12th term, but is now the 9th term. Okay, let's calculate that. 2 raised to the 11th power times 3. That gives me 6144. So the first term, the new first term is 24. The new 9th term, used to be the 12th term, is 6144. I can now use that if I put 6144 here times the 2. So let's do 24 minus 6144 times the 2. So I get a nice big negative number, and then 1 minus 2 is negative 1, so I can divide by negative 1, and the amount is 12,264. The confusing part about this is the fact that from here to here is a total of 9 spaces, but that number that's actually the 4th one in terms, we have to consider that A1 for the purpose of the series. So we're doing not this whole thing, we're doing part of it, so that you have to pretend that that's A1, even though it's the 4th term. This one's the 12th term, but because we're doing only 9 terms, we have to pretend that it's A to the 9th, or the 9th term, because it is just for this series we're doing it for. See why this can be confusing? Yeah? So I would say, for me, when I did this and realized, oops, I needed this number, this is what helps me to do a problem like this. I write out the numbers of them. Now, the first term originally was 3. Right? So I can say the 3rd term, or the first term was a 3, and then the 4th term you figure out using the formula is 24. You figured out the 12th term is this. So when I was finding the sum here from the 3rd term, or from the 1st term to the 12th term, it came to this total, because we went from 3 to 6144 and added them all up. The formula adds it up for you. You don't have to add each one individually. But when I go from this one to that one, I have to either do them all and subtract those, which is possible, or I have to see that this is my new first term and this is my new 9th term. 1, 2, 3, 4, 5, 6, 7, 8, 9. And pretend it's a whole new series with the 1 and the 9, but 24 to 6144 instead of 3. So doing it like this helps me to visually see it. My mistake that I want you to avoid too if you do it is to remember that, oh, the formula, if you use that other formula, it's the new number for the amount. This is A1, and that's A for whatever term it is, the amount of that term number. I started using both one. Okay. Thankfully, you don't see this that often. You see it with a 1 most of the time. But you want to be prepared for doing it that way too. Okay, now let's take a look at the fifth page. So on this one, we don't know the first term. We are given the sum at the eighth term. That's supposed to be 8 there. I'll make it a larger 8 so you can see. We're given the sum at the eighth term, which tells us that n is 8 and that r is 2. So now we want to find a1. So let's take a look at those two formulas, because we're going to use one of those to do it, because we have a sum. So this is where we're going to use the formula based on the information we have. So here in this one, we need to know the sum at, so this would be like 764, so with this. Here we need to know the first term. Here we need to know the r, and we need to know the n. So we need the r and the n, we have it. Over here, we need the r. We don't need the n. What we need, though, is the amount at that term. Well, we know it's the eighth term, but we don't know the amount. This information doesn't give us the amount. It gives us the sum, but it doesn't give you the amount of that one term. It just tells you the first plus the second plus the third all the way up to the eighth is 765. So we can't use this one, we're going to have to use this one. So I'm going to write it out here first. A1 minus A1 r to the n, and 1 minus r. Now, let's plug those in. 765 is equal to A1 minus A1 times the r, which is 2, raised to the 8th power over 1 minus 2. Now, a little thing, if we now calculate that, the problem is we've got A1 in there twice. A variation of this formula is now useful. What I'm going to do here, we'll calculate out some numbers and I'll show you -1. What's 2 to the 8th power? Not get too far ahead of myself. 16, 32, 64, 128. I think it's 2, forgot which one. 2 raised to the 8th, 256. So A1 minus A1 times 256. The negative is not a big deal. We just make the whole thing, or multiply both sides by a negative. That's a negative in front. This will become negative 765. This does not change here because multiplying by a -1 over here, and that just goes away. So what I have is this. At this point, if I divide by 256, I'm going to have to divide that also by 256. Yes?
Why is 765 negative?
Why is what?
Because it's 765 negative.
That -1 on the bottom here, I multiplied both sides by -1 to get rid of it.
Okay.
Yeah, because I don't like having a -1 on the bottom. I want to get rid of the denominator, so that's what I did. This is a lot cleaner, right? No fraction and no negative to deal with. It gets confusing, so I just use it as a multiplier on both sides. Now, here is where what you want to remember is this is actually nothing more than simple factor. Take A1 out of this, and you have 1 minus 256. So I take, this is A1 times 1, so I'm basically going to take A1 out of here, and I get 1 minus 256. Now I have only one A1. Simple little thing, but if you're not thinking about it, if you don't realize you can do it, then you get sort of confused. What am I supposed to do? You know, how do I handle two of these? If you divide by 256 to clean that one up, you divide in this one too, so basically it just gets worse. And it's like you dig yourself a hole, and you can save yourself from that by taking it out as a common factor. So negative 765, A1, that's negative 255. Divide both sides by the negative 255. I think that's what, is that right? That work? Yeah, that should work. 765 divided by 255. I get a nice, easy, if I divide that into that, I get a 3. So the first term is a 3. If it comes out to some weird decimal, you know you probably want to go back and check. Even if it's a decimal, sometimes it usually is something like a 2.5 or a 7.8, something that ends, or 7.25, something like that would be reasonable. Anything else might be right, but you should check and make sure that the numbers, how the numbers are set up. Okay, so let's review this, where we were basically looking to find A1. We could figure everything else out, but because there's two of them, if you put them on the same side or have them on the same side, equal sign, you can take out a common factor. This little idea that you can do this is a technique you can use at other times too. It actually is a useful thing in solving problems to enable you to take the same variable that's in there twice. You can basically make it one by taking it out as a common factor, and that makes the problem a lot easier. Okay, let's look at the 6th page. This one, aha. I did this one on purpose so we have the amount of that term so we can use the other formula. So we don't know A1, but we know the sum at the whatever term number. We don't know the n. Okay, let's see what we can work with. We know the amount is 128 at that term, and we know the ratio. And now, good practice to practice with have one of these. So that means from the formulas, this one requires that you have the n. This one does not. This formula requires that you have A1, which we don't have it, but we do have the total, and it requires that we have the r and the amount at whatever term it is. So we can use this one. So to avoid making a mistake with it again, I'm going to write it out first. The sum n is equal to A1 minus AN times R over 1 minus R. So we know the sum, 4, 1, 2 ones, and 8, 8, equals A1 minus AN is 128, the R is 2/3, and 1 minus 2/3. So this is nice here that there's only one A1, so we won't have to do that factoring in order to combine them, so we save a little bit of trouble there. There's enough other trouble with the fractions to keep us busy though in this one. So let's do some calculating with it. 4118 equals A1 minus, well,